Suppose we wish to answer the following question. A particle is projected up and it passes the same height h, which is unknown to us, at times 2 and 10 seconds. We wish to find h if g is equal to 9.8 meters per second squared. So to draw what we have some ground and there's some height h above that ground. Okay? And there's some ball which goes up. It passes h, it maxes out, and then it comes back down at some later time. So here is t is equal to 2 seconds, and here at some later time is t is equal to 10 seconds. And g is equal to 9.8 meters per second squared, and here we'll have this direction as being the positive y direction, which means that g points downwards. So that means that a is equal to negative g, which is equal to negative 9.8 meters per second squared. Okay, and just to clarify, this guy is negative because the positive y direction, which means if this is 1 meter, up here, which is higher than 1 meter, this might be like, I don't know, 100 meters or something. It's some number that's larger than 1. So that's the positive y direction. And since gravity always pulls things down towards the ground, gravity must be negative because it acts in the negative y direction. Okay, then we have that delta D is equal to V naught T plus 1/2 times A times T squared. This is some known equation for a particle that's moving. Okay. Then the height that we're interested in, or the displacement that we're interested in, is h. So we have h, so we actually have two cases here. We have t is equal to 2 seconds, t is equal to 2 seconds, and we also have t is equal to 10 seconds. And in both cases, like we said in the picture, in both cases, the height or the displacement is h. So here, h is equal to v naught, which we don't know, times 2 minus 1/2 times g, right? Because we said that a is equal to negative g. A is equal to negative g. So that's minus 1/2 times g times 2 squared. So I'm just plugging in this formula for t is equal to 2 seconds. Then at t is equal to 10 seconds, the displacement is also h. So h again is equal to v naught times 10 now, minus 1/2 times g, and it's negative 1/2 g for the same reason as before, times 10 squared. Okay. Now we can write this out as 2v naught minus 2 squared is 4. If you divide 4 by 2, that's 2. So this is minus 2g. Okay. Then we also can write this guy as 10 v naught minus, well, 10 squared is 100. Divided by 2 is 50. So this is minus 50g. Then what we can do is we can solve for v naught here, right? Because there's a v naught on this side and on this side. And what we want to do is we want to get rid of that v naught so that we have an equation just in terms of h and g, because we know what g is. It's 9.8, and we want to find h. So let's solve for v naught here. Well, if we add over 2g, then this is h plus 2g is equal to 2 v naught. But I can just get rid of that 2 and divide it over, and I've solved for v naught, right? So this guy here is v naught. So then I'm going to take this guy, and I'm going to plug it in to here. Okay, doing that, we get h is equal to 10 times this whole v naught, so times h plus 2g divided by 2, minus 50g. Okay, multiplying out 10 divided by 2, that's 5. So this guy is going to be equal to 5 times h plus 2g minus 50g. Multiplying this 5 out into both terms, this becomes 5h plus 10g minus 50g. Okay. Then this is equal to h, this is equal to h. What I can do is I can subtract this guy over to the left-hand side. So that becomes h minus 5h, so that's negative 4h, is equal to 10g minus 50g. So that actually becomes negative 40g. But what I can do now is I can get rid of the minus signs. And I can actually divide by 4. Right? So if I divide by 4 on either side, this becomes h is equal to 10 times g. So we have an expression for h, which is originally what we wanted to find. Right? We wanted to find h, or the height that this particle passes at t is equal to 2 and t is equal to 10 seconds. So now we just plug in for g, and we find that h is equal to 10 times 9.8, or 98 meters. So this particle passes the height 98 meters at t is equal to 2 seconds and t is equal to 10 seconds. And with that, I'll end the video. Thank you.